name is Lucca Paletta, and I will be telling you about my door unlocker. I chose the sandbox option for the engineering design project and decided to create a device that keeps my door unlocked. Many of us tape our doors to solve this problem, but this leads to the problem of either leaving your room unlocked 24/7 or having to remove and reapply the tape frequently. My device allows your room to be locked and unlocked at the push of a button. The first step was to do some preliminary planning and drawing, and then designing parts. I used the free CAD software 123D Design made by Autodesk. I printed 5 parts in total and ended up finding one of them did not work for my design. The parts I used were the bracket, spacer, servo attachment, and card holder. I use a Monoprice Select Mini 3D printer to create all the parts. I also use an Arduino Leonardo for this project because it's the only Arduino board that can connect to a micro USB power supply. There were several other parts I still had to gather. For an axle, I used the body of a mechanical pencil. This worked especially well because the pencil was not smooth on the inside, meaning smaller axles can be held in place inside by friction. I used a random card for the piece that physically blocks the latch bolt and dead latch plunger. The servo I used is a high-tech HS422. It has a torque range of 3.3 to 4.1 kg per centimeter, meaning that it was definitely overkill for this project. However, it was available and happily runs on the 5 volts the Arduino supplies. Construction was quite simple. The pencil was press-fit into the servo attachment and a nail was driven through the holes. And the card holder press-fit into the other end of the pencil tube with some blue tape to help hold it in place. Next was the Arduino program. This is the code that's in my Arduino in my unlocker. The code is in the style of a finite state machine. This means that the system moves from one state to another depending on input. Here you can see the 4 states: locked, removing, unlocked, and placing. I began with the state as being locked. I switch my states inside my loop. If the state is locked, I will first wait 100 milliseconds, turn the yellow lights and green lights off, and turn the red light on. Then I wait to see if the button has been pressed. If the button hasn't pressed, I change the current state to placing. If the state is placing, I turn the yellow light on and turn the green and red lights off. I put the servo at 0 degrees and then wait 1 second. After the second is over, I change the current state to unlocked. If the state is unlocked, I turn the green light on, turn the red and yellow lights off, then wait for a button again. If the button is pressed, it changes the current state to removing. If the current state is removing, the yellow light is turned on, the green and red lights are turned off, and we move the servo to 180 degrees. Then we wait 1 more second. Then we change the current state to locked, and we're back at the top again. The last step was putting all the wiring together. I taped it all to the wall, and made sure to put painter's tape on the wall first in case the thick double-sided tape damaged the paint. I connected the micro USB and watched it work. I find myself using it much more often than I thought I would. When I walk in my room in the afternoon, the first thing I do is push the button. Although it is small, the ability to easily and selectively open my room up to the outside world is a convenience that I have greatly enjoyed, and I know I would find it difficult to go back.